Hello everyone, I am going to explain you about how to convert a given context-free grammar into CNF, Chomsky normal form.
So now let us see how to convert the given CFG grammar into CNF form. First of all, let us see the agenda. What is CFG? And then we will talk about what is CNF, and then rules to convert a given CFG to CNF, and we will solve an example problem. So what is CFG first of all? It is known as context-free grammar. That is, a context-free grammar is a formal grammar which is used to generate all the possible patterns in of a string in a given formal language. And it is defined as four tuples. There is G equals BTPS, where G refers to a grammar which consists of a set of production rules. It is used to generate strings of a language. And T is the finite set of terminal symbols. It is denoted by lowercase letters. And V is the finite set of non-terminal symbols. It is denoted by capital letters. That is capital A, capital B, and like capital S, etc. P is a set of production rules which is used for replacing non-terminal symbols on the left side of production in a string with other terminals on the right side of production. And S is the start symbol used to derive the string. And what is CNF? CNF is known as Chomsky normal form. And now we will see when a grammar is in CNF. A context-free grammar is in CNF if all production rules satisfy one of the following conditions. The first one is start symbol generating epsilon. For example, A defines epsilon, or maybe any symbol defining epsilon. A non-terminal generating two non-terminals. For example, S defines AB. In this form, it is said to be in CNF. A non-terminal generating a terminal. For example, S is a non-terminal symbol and A is a terminal symbol. Now, what are the rules to convert a given contextual grammar into CNF? So these are the set of rules you have to keep in your mind so that we can solve the problem in a good manner. The first is the removal of useless symbols using generating symbols method. We will see this method one by one when we solve the given sum. And the second step is eliminate epsilon productions. To eliminate epsilon productions, the variable which is producing epsilon must be replaced on the right hand side of all other productions for the epsilon production to be removed. And the third step is to remove the unit productions. That is, S defines A, or a terminal symbol defines another terminal symbol. The non-terminal symbol defining another non-terminal symbol. It can be done by removing the unit production from the grammar, and in each place of the removed variable insert its production rule completely. Step 4 includes, that is, to check if the given grammar is in CNF form. If not, proceed as below. Step 5 is the production rule as the form where a terminal symbol is followed by a non-terminal symbol. Then introduce a new variable such that the new variable defines terminal symbol, and replace this new variable in place of the terminal so that it makes the rule as non-terminal symbol followed by another terminal symbol, which will be in CNF form. And the sixth step is the production rule as of the form where a single variable symbol is followed by two or more variable symbols. Then also replace it by a new symbol such that the single variable is followed by another single variable symbol so that it will be in CMF form. Now let us see a question to solve and check our knowledge. Now we have S defines ABC, A defines 0 AS, 0 epsilon, B defines S1S, A 1 1, C defines 1s 0 A, B 0 0. Now we should convert this one. So the first step is using generating symbols. We have to find the useless symbols and remove it. Let us check if there are any useless symbols in the given CFG. First of all, write every non-terminal symbol present in the CFG into the generating symbols. That is 0, 1, epsilon in this case. And then from 0, 1, epsilon, which ever variable can be derived should be written here. That is, from this epsilon symbol we can get a, that is a defines epsilon. So that a should be added to the generating symbols. And 0, 1, epsilon a, b, and b can be added from the rule that b defines a. And the third one is G is equal 0, 1 epsilon to A, B, C. C can be derived from C defines B rule. And the last one is S. S can be derived from A, B, C. So from this we can say that all symbols are reachable. Therefore, there are no useless symbols. Let us go move on to the next step. Eliminate the epsilon functions is the second step. Now, where do we have epsilon function here? See here, we have A defines epsilon here. That is one of the epsilon functions we have. Let us try removing this A defines epsilon. As in each place of A, we have to insert epsilon, and we have to keep the original form of that production plus the insertion of epsilon. That is, S defines ABC, and in place of A, now put epsilon, so it becomes BC. And A defines 0 AS, and in place of A put epsilon, so it becomes 0s, and here 0 as it is. And B S1s, in place of A here put epsilon and 1 1 as it is. C defines 1s 0 A, and now in place of A put epsilon, so it becomes 0, and then B, and then 0 0. Then we'll go to B defines epsilon, and we'll try removing this one. In each place of B, we will write epsilon, so that becomes ABC, and in place of B, epsilon, so AC, in place of B, epsilon, so C. A defines 0 as 0 A as 0 as it is, and there is no symbol B. Now move on to B. You will see that there are no B symbol in this production as well. But we are removing the symbol B defines epsilon. And we'll go to C defines 1 as 0 A 0 epsilon 0 0 and B. We have here epsilon because of this B. So now we'll try moving C defines epsilon in the next. Now we have S defines, and when we remove C defines epsilon, we'll be getting 1 as 0 A 0 0 0 and B. Try removing S defines epsilon now. Yes. Now we'll get ABC, AB, AC, A, BC, B, C. And in place of S, put epsilon, so it becomes 0. 0 A S. So in place of S, put epsilon, becomes 0 A. B. S1S, 1S. In S1S, try putting epsilon in the first place, so it becomes 1S. And then try putting epsilon in the last place, so it becomes S1. And try inserting epsilon in both the places, so it becomes 1. And then 1 1 A as it is from the given rule. C defines 1 as epsilon 1 0 A 0 0 0 B. So we removed every unit, that's every null fractions from the given grammar. Now we'll go on to the next step, that is elimination of unit functions. The first one is to remove B defines A. So in each place of A, write the production rule of A wherever A occurs. The B defines A production rule. So B defines S 1s and 1s S1 1 1 0 S, and then 0 0 AS 0 A. See 0 0 S 0 0 AS 0 A. These are all from instead of A we are putting this production rule here. And let us try removing C defines B. So in each place of B, put the production rule of the B, so that C defines B is eliminated, and that gives us C gives 1 as 1 0 A 0 0 0 S1 S S1 1 1 0 S. Let us move on to the next step. We have to remove S defines C, S defines A as well. So removing these things, we will be getting this one S as AB AC 0 S 0 0 AS 0 A as find the wow method. And at last we'll be getting the production grows as in this form, like 0 S, that is the terminal symbol followed by a non-terminal, a non-terminal symbol. So it's not in the CNF form. We can see that S1S is not in CNF form, 0S is not in the CNF form. So we have to introduce a new variables so that the given form takes the CNF form. For that, instead of having 0 as, we can introduce a new variable D1 gives 0, so that in place of 0 we will write D1C. So S defines D1C is of the form single variable followed by another variable, that is a non-terminal symbol followed by a non-terminal symbol, that is in CNF form. As we do this forward, we will be getting A, B, A, C, and for each terminal symbols provide a new variable symbol so that it becomes D2S, D2 for 1, so D2S 0, D3S, D3, BC, and it goes on. At last, we'll be getting A defines D2S 0, D1S, D3. So we can check that in every production rule we have the CNF form as mentioned in the first slide. So this is how we convert a given context-free grammar into Chomsky normal form. Thank you.